and then head over to the next talk by Rod Reed from Windlift.
Yeah, it's still windswept.
Windswept.
Sorry. So I think I'm going to have to start with a question for Filippo and yourself, Roland, which is how on earth am I meant to follow that? That's an incredible bit of technical data there, Filippo. Thank you. It's beautiful. So luckily for those of us with a slightly less technical bent, we're looking at a much more design problem and design focused method to going about how this was achieved. Now, for those of you that don't know, this is a rotary kite. Kites can spin as well, and that is one that was taken 4 years ago. Thanks, Roland, for finding that photo before AWEC. There's been very little testing of this system done in the past 4 years. Circumstances have led me to move a few times. Many variations of that were made and sewn from home. I had the luxury of being a house husband and making that. I then convinced Shell, of all folks, that it's actually quite a cool thing, and it's really efficient and working very well and has some really nice characteristics in terms of power out, continuous power out, and efficiency in terms of blades. So I was very lucky to be able to start planning. And at the start of that, the planning the system, we had that. What I was proposing at AWEC last time was that I'd be automating a 10 kilowatt system made out of those 3 stacked rotors that you see on the system on the right there. That, after a lot of design iteration, turned into the next design that you can see. It took a whole lot of work, there is a design reasoning report that we published recently. You'll find it on the LinkedIn, you'll find it on the Airborne Wind Energy Forum or the windswept.energy website if you want to check that out. I will not be able to do technical justice to that today, but in order to reach this design on the right, we had to go through some really stringent objectives, requirements, and we set ourselves an incredibly hard task, and we went through again and again for market cases that were really slightly over demanding. And this kind of came about as part of our funding. Shell have a habit in airborne wind energy of asking for quite a lot. And that's good on them, I think. You know, it's worthwhile having challenges. I think it's there was a lot we were looking to be able to achieve in that list there. Looking back to that design on the right there, you'll notice that the ground station has wheels on it. We were looking to take that out. One person would be able to deploy the whole system. In some of the later bits, you'll see that the backbot, that's the wee bit, that's a launcher there. Loads of people have built kite controllers. We got around to building a launcher. That's the bit that's meant to move around the ground station and be able to handle and launch and land the kite. And yeah, we've actually had quite good fun. Actually, this is what it was meant to do. Is this going to play is there an animation there, Roland? Is that, yeah. So it was that launcher, it was the bit at the back there, the stick, and I think I showed this last time. Basically, it goes up and it goes down and pulls the kite back in. And the magic way that works, I like to do things really simple because, you know, I can't present things like Filippo. So next slide. This is also a video, so hopefully that's playing. This is what I built in order to be able to do that. This is the launcher, and instead of making it completely roboticized, this is the part at the top. There are 2 fair leads there, and what happens is a ball on the lift line goes through the lower fair lead, you can see it in green, jams into the red one, wedges in that, and lifts up that line. There's a further line. This is it. Yeah, except we don't use a wooden block, we use something. This was the very first demo, but it's just one of the cleanest ways of showing. The line running down, let's go to the turbine. So the turbine always ends up held at the top of that mast, and the lifting kite is able to launch from the top of that mast and come back down to it and spool. And you can also see a couple of steering winches on there as well. We haven't had the chance to implement that or test that yet. This is the minimum viable product system we were looking at building. So hopefully this isn't sounding too much like marketing spiel, but we ended up going to a single rotor system because we needed to know about scaling up to a 20 kilowatt system. This rotor was 12 kilowatt capable. We were looking at the losses in the lines and the losses in electricity generation, and we needed to overspec our rotor, and we needed to have a lot of weight in that. It's got the wrong transmission system on there. Sorry. The transmission system, we had to make sure that all the Euler bending was going to be fine. We were overspecking the system so that it wasn't going to snap when it loaded up with torque. The torque transmission system we were reckoning it was going to be about 3 degrees of rotation running at per ring on that set. You'll notice those rings, actually, by the way, they're quite a narrow set of rings coming down to the ground station. That's helpful so that they don't have to travel so fast through the air, but they are transmitting the power. So there's a bit less drag considering the number of lines that are moving about. We'll get onto the multi-kite system on that later, though, the multi-rotor thing. Here's the design reasoning report. So good, we've all read through that, and there's more of it off to the side. The rotor weight was something that killed us. So that rotor that you saw on a couple of pictures back, that's the mass calculated here is based on the old way that we were making these rigid rotors, which is pure fat chunks of rigid foam in big lumps of plastic. Then in this case coated in carbon fiber composites, and so it was actually it's a beefy bit of rotor, probably too much. And this 8-meter lift kite, surprisingly, wasn't capable in the tests of generating enough lift. I say surprisingly, we knew there was going to be a limit, but damn it, the wee yellow kite down at the bottom there is 1.8 meter, and it pulls as much as that 8-meter kite. But that was thanks to Peter Lynn in New Zealand. I got to sew that on his home sewing machine, and that was truly an honour. So when you mix the rotors with the performance we were getting from that lift kite, well, you don't end up with all this mess, but what this shows is various simulations of different stretched out kite turbines, and the saggy one is really what we were looking at getting if we put this in the air. It wasn't even going to lift the transmission. So we were very disappointed with these wind stats that we got out. And if you look at this set of line tension results with what the rest of the airborne wind energy companies get, we're that little cute. We're the cute little bit down there. Didn't do so well. But some of you are off the charts the other way in this, so well done. I'm impressed with that. What does that mean going forward? Well, if we're going to launch something like this, we need to put something better at the top of it. It would be better if we had another type of kite, but I've got that same slide again. Sorry. Really, we should change from something like that to something that's multi-kite. And Peter Jameson, who we've had the pleasure of visiting us, and is a bit of a legend in airborne wind scaling and induction and turbines and mass scaling, and has presented on multi-rotors and all sorts of wind turbine standard designs. He says, keep your rotors the same size and stack them. You should be good. And he's way more technical than me. Filippo knows what's going on with this slide. And here's what we could do, though. If anyone knows how to lift up one of these things, Fabi, go for it. And if you want a turbine from me, I reckon you can get smoother power out than you're getting at the moment. And I reckon you can get more power out than you're getting at the moment from your kites. That's maybe controversial, but I don't have the background of hundreds of, loads of PhD work and such. I'd love it if there was a lot more. We've got 1.5. That's pretty good. Other ways to do it, we could actively pull in and deploy from the ground station. We could steer through I've done some steering lifter kites, but I'm not impressed with the results I'm getting out of those either. And again, I'm asking too much in the low wind And some people may say I'm a bit of a chicken for having scrapped and not asked for more funding when I did, but I wasn't convinced of the reliability of the system, and I wasn't prepared to go ahead with something like that. So, yeah, this was one other effort we tried, and you could try all sorts of exotic nonsense. And I'm potentially going to test something about cyclic bank lifting, and maybe deploying Kite turbines in structures that aren't airborne. So I shouldn't show that at an airborne wind energy conference. Yeah, I think we're good on time there, yeah?
Yes, we are good on time.
Sweet.
Thank you.
No worries.
Thank you. My first idea would be to just have a bigger kite, right?
Well, the problem then is, so there was no, we didn't have the pitch angle on the lifter kite. We didn't have a control for that. So when you're trying to pull that back down onto that backbot, that launching mast, then in high winds, that's really awful. So you can pull it off to the side, you can steer it off, and yeah, we were going to take that right. That was yaw stalling, is what we've done before in the field, and that robot is to replace me. But I really hurt my hand with a 5-meter kite last year, and yeah, I know if that force was on the top of that mast, I would be struggling to keep that mast in. We would have to really make things a lot stronger. So safety was one of the reasons that things have changed at the moment.
Okay, thank you. Are there any other questions? One.
Hi, this is Eduard, Kite Power. Did anybody ever do any more scientific calculations on your concept, and how promising is this concept with respect to other methods?
Anyone who's looked at it that isn't me is more scientific about it. Ollie has done a PhD. Ollie, who helped host, and from Strathclyde helped host EWIC 2019. Thank you. And Hong Yu, who you'll see here. She also has Jouet, a student that's looking at it at the moment. Yeah. And Christophe Beaupoil, he's doing another rotary system, and he's done torque as well. So
yeah, it looks really interesting, but I'm relatively new in the world, so I was wondering whether or not it was how viable this concept is in terms of comparison to other ideas.
Yeah, I mean, we're all wondering how viable it is. Certainly in terms of putting something together instantly in a loft, as somebody had the luxury of being a house husband, yeah, it was super viable with a sewing machine. But you saw, like, Reinhardt's started out with a sewing machine and struggling. It's we don't know. I'd love to know. Yeah.
Thank you for the presentation.
Thank you for the question.
There is one more question. Can you reach the microphone back?
So I just wanted to comment that I also did a few of these calculations, and they sort of pan out really well, actually. So yeah, it should work.
Yeah. Thank you, mystery presenter.
We just need to lift this tension structure, right? The torque transfer structure into
for torque transmission. Yeah,
yes,
but then deploying, that's the harsh piece. So the way we had it was really simple, pre-stretched out up to the mast, and so you always had it ready to fly, and you'd either take that out of the wind and you could drop it for safety's sakes. But if you're going to deploy from a ground station, it's really hard. Christoph's looking at cyclic pitch control for his rotors and launching from ground station there.
Okay, then thank you very much again.